So last lesson we learned about the arithmetic sequence, and hopefully you remember that there was a formula to work out the terms. Anyone memorized it? Did you memorize that or read that?
I memorized it.
Oh, good.
You read it.
The good news is that it is on your formula sheet, so but it's good to know it too. The second formula, the second type of series is the geometric series that we're going to be learning about today. And it is a series that is found by multiplying the preceding term by some constant to get the next term. And we call the number that we multiply by the common ratio, and we give it the letter R. If you need to find the ratio, you will take one of the terms in the sequence and you'll divide it by the one in front of it. Obviously, you'd have to at least start with the second term and divide it by the first term, or third term divided by the second term, okay? A geometric sequence, any term of the sequence with a first term A and a common ratio of R, can be found by this formula here. If you have the previous term, you can just multiply it by R to find the next term. Okay, good, but not very useful compared to the next one. The next formula here, this is the one that's on your formula sheet. To find the term T of n, it is A times R to the power of n minus 1. And there's a reminder here, n is the number of terms, A is the first term, and R is the common ratio. An arithmetic progression, remember, was an AP, so a geometric progression is going to be known as a GP. Let's do some examples. Number 1, if the following sequence is a geometric sequence, find the common ratio. So to find the R, you just have to take two consecutive terms. I'm going to take the first two, and I'm going to do the second term, which is 4.5, divided by the first term, which is 3. 4.5 divided by 3 is 1.5. You could have done 6.75 divided by 4.5 and you should get the exact same answer. Okay, not every question is going to tell you what type of series it is. You will have to be able to look at them and tell whether it's an arithmetic, whether you're doing the formula from yesterday or the geometric like today.
How do you know?
If it's adding something on, it's an arithmetic one. If it's multiplying something, it's a geometric. Question 2. Find the 17th term. So I'm trying to find T17 in the series that is given there. So it doesn't actually tell me that it's geometric, although we'll assume that because we're doing it today. But you would check. You'd look at that and you go, to get from 3 to minus 6, I have to multiply by minus 2. Multiply by minus 2, yep, gives me that. Multiply by minus 2, yep, gives me that. So I know that it's a geometric. Quickly, come in, guys. Quick. We've already started without you. The first term in the series is A, which is 3. And as we just discovered, the ratio is minus 2. So using our formula that I've just introduced you to find a term in a geometric series, it's T of n equals AR to the power of n minus 1. And I'm just going to sub all these things I've been making a list of over here, I'm going to sub them in. So to find term 17, that does mean, by the way, that n is 17. You can write that in your list as well if you need to. A is 3 times by R, which is minus 2. When it's a negative number, it is good to put that in brackets to make sure that the negative is also included with the power. And the n minus 1 would be 17 take away 1. Now, please don't ever, if you're simplifying these things, you do not ever multiply the 3 with the minus 2. Okay, because the 3 is not to the power of 16, only the minus 2 is. So please type that in your calculator as it is, and you should get 196,608, which is quite a big term, but you can imagine if you're multiplying things, they're going to get big quite fast. All right, part B. Find an expression for the nth term of the series. That just means I want to use the same A. This is still the same question. A is still 3 and R is still minus 2. I just want to find the general term, meaning I want n to stay in my equation. So using my formula, T of n equals AR to the n minus 1, A is 3, R is minus 2 to the power of n minus 1. And as I said, don't multiply that 3 and that minus 2. It'll have to stay like that. Okay. Next page. Question 3. If a sequence is geometric, which term in 2, 6, 18, ... which term is the 13,122nd? Where is that? What position is that going to be in? So let's write down what we know. We know it's geometric. We know the first term, which is A, it's 2. To get from 2 to 3, you would be timesing by 3, so that's my R. R is equal to 3. And I know the whatever, I don't know what position it's in, but the term that I'm given is 1, 3, 1, 2, 2. And I'm going to go backwards through the formula to try and find out what that n is. So let's write the formula down. The term, subbing it in, 1, 3, 1, 2, 2. A was 2. R is 3 to the power of n minus 1. Don't times the 2 and the 3. I'm going to say that a lot because it happens. People try to do it. Don't do it. To get that n, I want to solve for the n. I want to move whatever I can away, so I can move the 2 away. Divide the 2 across to the other side, and that gives you 6, 5, 6, 1 equals 3 to the power of n minus 1. Now you do have choices here. You could change it into a log, or you can actually write that number as a base of 3. I don't mind. Either option's fine. It is 3 to the power of 8. I'll do another one with a log, so I'll do this one this way. So if you can make the bases the same, that means that the powers must be equal, and that means that n minus 1 equals 8, which means n is going to be equal to 9. So that term, the 13,122, is the 9th term in that sequence. That's what that means. Question 4. The first term of a geometric series is 45, so that's the A. The 10th term, which means you write that down as T10, is equal to 23040. Find the common ratio. So I'm trying to find the R. You could also put in there that I'm going to be using n is equal to 10 because I'm using that 10th term. So that means I'm going to use my formula again going backwards to find the R. So let's write it down. Term formula. AR to the n minus 1. The term that I've been given is 23,040. The A was 45 times by R, I don't know yet. And N, which is 10, I'm just going to subtract the 1 straight off and put a power of 9 up there. Okay. To get the R by itself, first of all, divide the 45. So that will leave 512 equals R to the power of 9. How do I get rid of a power of 9? Nope, don't need to do a log. A 9th root. Okay, so on your calculator you will need to find the 9th root of 512. Do you all know how to do that? It is 2, good. Easy, right? All right, one more question. Part 5, find the first value of n for which the term of the sequence 1, 3, 9, etc. exceeds 2,000. So what do we know? First term is 1. It's geometric, so R is equal to 3, good. And I know that I want the term, so I want to know when the term is greater than 2,000. That's what exceeds means, greater than 2,000. I do also have my formula, if you need to write that down, AR to the n minus 1. That's my term formula. So using my formula here, I'm going to sub in these values that I've been given. So A is 1 times R, which is 3, to the power of n minus 1. That's my term. And that needs to be greater than 2,000. And I have to solve that to find n. Now this is not going to work out as a nice whole number like the other one that I did with the power, so we're going to have to use logs for this. So first of all, the 1 that's out the front there, because it's times, you just divide by 1, it's gone. You're just going to have 3 to the power of n minus 1 is greater than 2,000. Now you can do a sliding base with an inequality there as long as you keep things on the same sides where they are. So if I leave the n minus 1 where it is and I slide the base of 3 across to the other side, it is log base 3 of 2,000. Now we can't do a log base 3 on our calculator, but hopefully you remember how to do a change of base. To do a change of base, this is what you type in your calculator. I'm going to do ln because it's shorter to write. You just type in ln of 2,000 over ln of 3. You can change the base to whatever you want. Log of the first one over log of the base. You could do log base 10 if you want, you'll get the same answer. Type it in, what do you get?
6.918.
Cool, so I'm going to go 6.92. And finally, add the 1 across. N is greater than 7.92. So if n has to be greater than 7.92, it means that n has to be equal to what?
8.
N has to be equal to 8. So I'm going to go, therefore, the 8th term is the first to exceed 2,000.
Calculator came up with 3 to the 5 is the first one.
3 to the 5.
3 to the 8 is 6,500.
One sec, let me just stop this.